Good morning. So I just got a notice that the video I had posted for this lesson had no sound. So I'm going to walk us through it again. I'll leave that video up and then I'll go and post this video with sound. It'll take a little bit of time, but I just wanted to be able to talk to you as I went through this video. We're going to do some story problems. I'm going to start by working through this first problem, and then I highlight some things on the second problem, and then I'm leaving the third one for you to do as homework. So I'll go ahead and get started with this first one. This is about the St. Louis Arch, Gateway Arch. Some of you, I'm sure, have been there. It's not a perfect parabola, but as they point out here, it can be modeled as a parabola. So they're modeling this as a parabola with the equation y equals 630 minus 0.00635 x squared, where both x and y represent distances in feet, and the origin is the point on the ground directly below the arch's apex. So as you can see in the drawing, they drew in our x-axis and our y-axis, and by apex they're talking about this point up here, which would be the vertex. So the vertex, or the apex, is that top point. So the biggest part of a story problem is just trying to identify what it is we're looking for. So the first thing they do is they tell you to find the x-intercepts. So to find the x-intercepts, I'm going to go back here and color code this, the x-intercepts. We're looking for, essentially, for these 2 points. And we know that for finding the x-intercepts, it would be where y is 0. And if you've already watched the other video, then you would see me setting this up. So we're looking for where y is 0. And this one, because there is no x term in standard form, there's just an x squared, we can actually solve this just by subtracting, sorry about that, just by subtracting 630 from both sides. And dividing both sides by the coefficient of x squared. Where we get x squared then is approximately, let me go back and find my calculations for this. Approximately 99,212.6-ish. And then when we take the square root of both sides of that, we get plus or minus, it's approximately plus or minus 300, I think it comes out to be 314, like 0.98, or we would say positive or negative 315 for the x-intercepts. And then it says, what does this information tell you? That means we're looking at 315 feet to the, we'll say to the right, from directly underneath the vertex, and 315 feet to the left, directly underneath the vertex. So when they ask how wide the arch is, we're looking for what I'm marking in green up here. We're looking for that distance. So we're actually looking for it to be about 630 feet. And then how tall? Looking at how tall, we're looking for the y-intercept here, because we're looking for that solution at the top, that vertex point. And since that is on the y-axis, we're looking for the y-intercept. So we could simply say y equals 630 minus, if we're going to put 0 in for x squared, we're going to get 0. So we're looking at, again, 630 feet. And then to sketch a graph of this, I think On my last recording, I was probably neater because I was taking my time. Let me go through here and draw in. And I'm not looking for you to put this on a grid necessarily. It does just say to sketch it. So this would be a situation where I would know that this up here is 630. And then I'm looking at these points as being 315 and negative 315. And this would be the sketch then of that parabola. Okay. So again, it's just interpreting what it is we need to find. Looking at this second second problem, this is a yo-yo problem. So Mo is playing with a yo-yo. He throws the yo-yo down, pulls it back up. The motion of the yo-yo is represented by y equals 2x squared minus 4.8x, where x represents seconds since the yo-yo left Mo's hand, and y is the vertical height with respect to Mo's hand. And then I like this note that they give you here. Note that when the yo-yo is in Mo's hand, y equals 0, and when the yo-yo is below, y is negative. So they're treating that distance below his hand as a negative distance to indicate direction, not to indicate a distance. You can't have a distance that is negative, but it has a negative direction. So the first question says, how long? We're looking for an x because this is a time. How long is Mo's yo-yo in the air before it comes back to Mo's hand? So it releases from his hand at 0, 0, 0 time, 0 height. If we think about this in terms of a graph, it releases from right here at 0, 0. It goes down, and then over time it comes back up to the hand. So we're looking for the other x-intercept. So it says, what do you need to find this? We need our x-intercepts here, which means we're going to set the equation. The equation equal to 0, and then honestly, because there's no constant term here, this is a really easy one to factor and use the zero product property on. So I'm going to put a note over here that I would use the zero product property. You can factor an x out of this equation. In fact, pull it out and put it in front, and then you have two terms, x and the other factor, and set them equal to 0, and you'll have your two x-intercepts, and you can answer this question. For part B, how long does it take for the yo-yo to turn around? That is, to start its return to his hand, we're looking for the x-coordinate of the vertex. We're looking for the x-coordinate of the vertex. So once you have your x-intercepts, you can find that x-coordinate of the vertex. How long is the yo-yo's string? So in other words, you need to know how far below his hand it can drop. That's the y-coordinate of the vertex. And you guys have strategies for that. And then a sketch. So it'll look something like the sketch you see up top there for part A. But you're going to have points on there labeled to be able to answer. And then you've got 54, a similar type situation. It's about a rocket off of a launch pad, and they do give you an equation in here that models the path of that rocket, how high and how far it has shot off, and then a couple of questions to answer for that one. So your homework is to finish up the second problem, 37, and then complete 54. And again, I apologize that the sound was off on the video, so hopefully this helps, and we'll get this uploaded right away.